guys talking about math? It's my favorite subject. Can we talk about it?
Oh yeah, come on, join us.
Yeah. Alright, so starting with the derivative, turn left. Starting with the derivative and integrals.
Hip, hip. Hip, hip. Hip, hip. Hip, hip. When you're on a holiday.
Isn't this awesome, guys? Trig has like so many different applications.
Yeah.
I mean, like, even in architecture, isn't the definition something like the process of designing and constructing buildings and other objects or something like that? I'm pretty sure they use trig a lot in architecture. Like, say, look at that playground over there. That looks like architecture-y. Let's go check it out.
Hey look, there are plenty of triangles in this playground.
Ah, that's true. Look, these are equilateral triangles.
What are triangles used for?
Triangles are used because they're structurally sound and because they can distribute the weight along the ground, and it makes it more safe for kids too.
Trigonometry.
Here's a picture of the swings you just saw. We are now going to do a problem with the real-life situation. Mike was swinging on the swing set. While Bob watched, Bob decided he wanted to find Mike's distance above the ground using a sine or cosine curve. He starts timing Mike and sees that after 3 seconds, Mike reaches his maximum height. Then, 2 seconds later, he reaches his lowest point on the swing. Bob measures Mike's highest point to be 11 feet and his lowest point to be 1 foot. Write an equation that will find Mike's height after t seconds. So the first step is to identify the equation that is going to be used in this question. Y equals a times sine of w times t plus k, with a being the amplitude, w being the period constant, and k being the center of oscillation. The second step is to solve for the amplitude. The amplitude is just the half of the difference between the max height and the minimum height, which is just simple math. It comes out being 4. The third step is to find the center of oscillation. Oscillation is basically just the act of moving back and forth, so like what a swing does. To find this, we must add the max height and the minimum height, and have the sum. Almost like we solved for amplitude. K comes out. The fourth step is just to find the period constant, which is determined by the cycle period. This involves the time it takes to complete the entire circle. We just add the time it took Mike to reach his max height, and the time it took to reach his lowest point. It comes out to be 2 pi over 5 seconds, because the number we found was just a period and 2 pi makes it a period constant. Now we just substitute the numbers we got for the unknowns into the equation. So it's y equals 4 times the sine of 2 pi times t over 5 plus 6. We can then use this equation to find what height Mike is at any given second.
Hey, don't you think we need some protection from the elements?
Guys, we just need to build a shelter like a canopy. Something with like a, slanted roof.
How are we supposed to find the optimal slope for maximum protection?
Let me think about this. Ah, I see. We can use trigonometry to calculate the length of a hypotenuse and find the slope.
Yeah, sounds good.
Alright. So guys, how's this canopy, huh?
Wow, I feel so sheltered from the elements.
So much protection.
See guys, anything's possible with the power of math.
The power of math.
Yay!
Here we have another problem to go with the canopy you just saw that was built with the power of math. In order to build this canopy, the architect had to find what slope would be the most efficient. This is done with simple trigonometry. However, we wish to find the slope that the architect used by using data gathered from the finished structure. Theta has been found to be 33 degrees, and the length of the entire structure is 13 feet. Using this given information, find the slope of the canopy. The first step in doing this problem is to identify what it is we're trying to find. We are given the 13 feet that is adjacent to the theta. We also know that the slope is rise over run, and that the adjacent is the run. So we need a rise. The rise also happens to be the opposite. Now we have opposite and adjacent. According to SOHCAHTOA, those are the key components. Next, we have to set up the equation, which is the tangent of 33 degrees equals x over 13. This step is almost just as easy as before. Now we just solve this equation with the simple algebra skills. However, we do need a calculator to find the tangent of 33 degrees. Then, we multiply that number by 13. So we have our missing number, which is 8.44 feet. The slope is either 8.44 over 13 or just 0.649.
That's pretty good there now.
Hey, so these lights are spaced really far apart.
Yeah, why do you think they designed it like that?
I don't know, but they didn't really think it through. There's dark spots in between them. Maybe we could use some kind of math to solve it.
Maybe some trigonometry.
Yeah, trigonometry, huh?
Yeah.
Alright.
This is the same lamppost Mike just pointed out. If he wants to find out how far away the lights need to be spaced, he'll need to draw a right triangle. The distance from the ground to the light is the long side of the triangle. Since Mike is 5.5 feet tall, he estimates that the long side is about 12 feet tall. Mike knows that the short side of the triangle must be the length between the base of the light post and where the light beam ends. Counting his steps, Mike estimates this length to be 5 feet. To find the third and last side of the triangle, Mike uses the Pythagorean theorem. It has the form of a squared plus b squared equals c squared. So you plug that in, and it's 5 squared plus 12 squared. And multiply those together, it's going to be 25 plus 144. That equals 169. And the square root of 169 is 13. So Mike discovered that the hypotenuse is 13 feet. Now that Mike knows the path of light from the tip of the post to the ground, he can get an idea of how much area he is lit up. He thinks that for best coverage, the light triangles should overlap. First, he needs to find the midpoint of the hypotenuse by dividing 13 in half. Then he makes an imaginary line that is perpendicular to the short side and also intersects the midpoint. To achieve the perfect spacing Mike wants, all he has to do is space the other lampposts far away enough so that the triangle of light touch the point formed at the intersection of the perpendicular line he just drew. Now, there should be enough ground coverage so that Mike and his friends don't fall and break their necks while they stroll about in the dark.
What is love? Baby, don't hurt me no more. Baby, don't hurt me.